Hi, I'm Andy Goodmans, General Manager and VP of Engineering for Databases for Google Cloud. Thank you for joining us for Google I/O. We have an exciting product announcement to share with you in this session. For developers and enterprises alike, the cloud offers organizations agility, cost savings, and differentiated capabilities that allows developers to do more than they could before. That's why 75% of all databases are expected to be in the cloud this year. Imagine, 40 years of proprietary databases placed on premises are moving so rapidly to the cloud. It's amazing. New applications are already being built in a cloud-first manner, and existing applications are moving to the cloud at a rapid pace. Today, those customers already have many options on Google Cloud. We offer a full suite of database services, from in-memory services like Memory Store for Redis, to relational database services like Cloud SQL and Spanner, to non-relational database services like Firestore and Bigtable. All these services help manage the complexity of running your databases so that they are secure, simple to use and operate, and make app development faster and easier for you. And we're really excited about what these databases have accomplished, both in terms of their ability to scale and the number of customer workloads we've served. To give you a sense for the scale at which our databases operate, Spanner processes over 2 billion requests per second at peak. Isn't that amazing? Bigtable, our fully managed key-value database, processes over 5 billion requests per second at peak. Firestore is our serverless mobile-optimized document database, which powers applications with more than 750 million monthly active end users. So this demonstrates the scale of the workloads that our databases support. Our databases help our customers modernize their apps and unlock the value of their data across the GCP ecosystem. For example, more than 650,000 Google Kubernetes Engine pods securely connect to Cloud SQL, and BigQuery users query over 125 petabytes of data in Cloud SQL on average in a month. That said, we still have more work to do to support customers moving to the cloud, especially for customers coming from legacy proprietary databases. These customers are not moving to the cloud with their applications as is. They're working hard to modernize by freeing themselves of expensive licenses and hostile business practices, adapting to new requirements around vendor portability, and taking advantage of innovations that only the cloud can deliver. Those customers are increasingly standardizing on open source, and in particular, one open source database, Postgres. And there's a reason for that. It has everything you would expect from an open source database. The portability that has become so important to enterprises, and a license-free cost model that enables companies of any size. But what's so special about Postgres is its rich functionality and extensibility. It provides a similar, and in some cases better set of functionality than the expensive closed-source alternatives. It supports parallel query, partition tables, store procedures, replication, change data capture, rich data models, and more. Postgres' ecosystem of extensions, from foreign data wrappers to geospatial support, helps it address a wide variety of use cases. It's also ubiquitous. It plugs into every major application development framework or ecosystem. It's adopted by millions of users in every industry, from startups to large enterprises, and has demonstrated itself in demanding customer environments time and time again, giving others the confidence to use it in their own applications. And the community is friendly and welcoming, with lots of support for those getting started. We've worked with lots of customers on Postgres, running every scale of application, from early development to true enterprise-grade applications. And what we found is that despite the benefits, at times, there's too much burden on developers to make it run well in production. We see developers struggle to tune parameters and configure their setup, make difficult trade-offs between reliability, cost, and performance. They're using layers of proxies to get high availability, carefully managing storage and memory resources to prevent out-of-disk and out-of-memory errors, and navigating the impact of Postgres vacuum. Replatforming business-critical workloads onto open-source databases can be daunting, especially when workloads have strict scalability, performance, or reliability requirements. Enterprise customers moving from legacy proprietary database expect additional support in managing and scaling their applications. And finally, we think there are opportunities to help customers do more with their operational data, like real-time insights and the integrated use of AI and ML. Don't get me wrong, we think Postgres is phenomenal. It's a phenomenally mature database. It's just that customers have asked us to help them solve some of these problems. We believed we at Google were uniquely positioned to address these user pain points. So we started on a journey with Postgres, the world's most loved relational database, and added the elements we know best: cloud-native architectures, using Google's unique disaggregated compute and storage architecture to scale performance and improve availability, an awesome engineering team assembled with database experts from across the industry, and our DNA of AI and ML to make everything about running a database easier. Alloys are made by melting and fusing elements together to create something new with improved properties. Today, we're excited to announce the preview of AlloyDB for Postgres, combining the best of Google with full Postgres compatibility. AlloyDB is a new database service that is ready for your top-tier relational database workloads. AlloyDB provides industry-leading performance and availability, so it can handle any commercial-grade workload you throw at it. Full Postgres compatibility means regaining the freedom to run your applications when and where you want, and benefiting from the entire Postgres ecosystem. AlloyDB is 4 times faster than standard Postgres for transactional workloads. It's also more than 2 times faster than Amazon's comparable Postgres-compatible service for transactional workloads. This means you can scale transactions well beyond previous limitations and get better performance out of fewer resources and much smaller database instances. And best of all, query performance scales linearly as you add more compute resources. We also know that customers use Postgres and other operational databases for a variety of workloads, including real-time insights and reporting. AlloyDB delivers up to 100 times faster analytical queries than standard Postgres. Isn't that amazing? That's with 0 schema changes and no need to move data around. We're really excited about what this means for end users. Super fast, real-time analytical queries directly against your operational database. At AlloyDB's core is Google's innovative approach around completely disaggregating compute and storage. This approach has enabled us at Google to build truly unique and differentiated systems, where we don't just separate compute and storage at fixed layers of the stack, but we have complete flexibility to add compute as much or as little as needed within a system, which enables us to deliver the most performant, efficient, and scalable systems. For AlloyDB, we've built a new intelligent database-optimized storage layer that scales separately from the database instances and offloads work from the primary. But we're not the first to do that. What's so special about AlloyDB is that we're leveraging Google technology to disaggregate compute and storage at every layer of the stack, including the storage layer itself. That allows us to deliver a truly scalable system with predictable high performance for both reads and writes, and lots of flexibility to continue to innovate in creative ways. Zooming in a little bit, you can see the storage layer in more detail. It's powering fast, predictable performance by eliminating I/O bottlenecks and offloading work from the primary database instance. And it's regional by default, enabling fast, bounded recovery times and low-lag read replicas. But again, what's so important here is that, as you can see, the storage engine itself has disaggregated compute and storage. This means that we can very transparently rebalance load if there's a hotspot and make sure that a particular shard gets the compute resources it needs. It also allows us to scale I/O because we can flexibly add more processors in the intelligent storage engine to adapt to the load. Again, this is all fully transparent to the database layer. The storage service isn't the only technology powering fast, predictable performance. AlloyDB features automatic data tiering between DRAM, and ultra-fast cache, and durable storage. That means you get the availability and scale benefits of our scale-out storage service, plus the price performance benefits of tiered caches. We also intelligently organize your data between those caches. In DRAM, we use both row-based and columnar formats to maximize query performance. Machine learning infers your workload and auto-populates these caches effectively. We continuously monitor your workload and dynamically decide which columns and tables belong in the columnar store, then automatically convert them to columnar format. And so when a query comes in, the query planner will smartly choose between row-based, columnar, and hybrid execution to optimize performance for every query. Within the columnar store, AlloyDB builds on the single instruction, multiple data, SIMD capability of modern processors to speed up query execution. Cache misses go to a second ultra-fast tier cache before hitting durable storage to maximize price performance. This architecture allows us to deliver the best performance for both transactional and analytical workloads. The vectorized columnar execution engine speeds up analytical queries, and the intelligent storage service powers very low-lag read replicas, so you're always querying an up-to-date version of your data. That means you can run super fast, real-time queries on your operational data directly with zero impact on your operational workload. No schema changes, no additional indexes, no additional configuration. In fact, you might even be able to drop your existing analytical indexes to further improve transactional performance. AlloyDB delivers real-time insights out of the box. To see that in action, I'm going to turn it over to Viral.
Hi, I'm Viral Shah, a lead engineer for AlloyDB. As Andy mentioned, AlloyDB allows you to supercharge your queries with zero schema changes. Let's walk through a call center use case to see how much faster AlloyDB is than PostgreSQL. Let's say I'm managing a call center CRM database. I have 1 terabyte of data partitioned by day of month with approximately 100 GB on disk size for 2 months of data. The tables hold the client's interaction data, including the time they were put on hold before the call was answered. My CRM database was initially built as an operational store to serve our call centers and continues to do so. But I'd like to get some quick insights on our users' experience. So I'd like to run a few queries. First, I'd like to understand the average customer's hold time during the months of July and August of 2021. As I'm building my dashboard, we will be running 3 more queries concurrently that are looking for the total number of clients who called during those months, the client that had maximum hold time, and the time of the peak call volume. We have built a dashboard in our favorite visualization tool, Looker, to compare the performance of the two databases. On the left side, we have an AlloyDB instance, and on the right side, we have a PostgreSQL instance. The results of the 4 queries are displayed below each of them. Before we dive in, let's talk about the configuration. We have 2 like-for-like VMs with 32 cores and 256 GB memory in each. For the AlloyDB VM, we have provisioned a larger 60 GB columnar cache alongside a smaller 10 GB buffer cache, whereas the PostgreSQL VM has a large 100 GB buffer cache. PostgreSQL's buffer cache and AlloyDB's columnar cache have been pre-warmed and populated with the tables for 2 months of data. I'm now going to rerun the queries by refreshing the Looker cache. As you can see, AlloyDB has already processed the query, whereas PostgreSQL has some work to do. I think we'll have to fast forward this video to allow PostgreSQL to catch up. But how fast was AlloyDB? Let's look at this dashboard to dive deeper. We see that the queries running on PostgreSQL instance took an average of 164 seconds, while running on an AlloyDB instance, they completed in less than a second. AlloyDB was nearly 160 times faster for these queries, and I didn't have to add any indexes or change any schemas. Cool.
That was a cool demo. Thank you so much. We're so excited about the performance that AlloyDB offers customers and the new capabilities and insights it unlocks. But this architecture also enables a new level of reliability and availability. We offer a 4 nines availability SLA that not only includes unplanned failures, but database maintenance as well, so you can better serve your end users. AlloyDB automatically detects and recovers from most database failures within 60 seconds, independent of database size and load. It means recovery is not only fast, but also very predictable. Our architecture also supports online instance resizing and database maintenance. The primary instance can resume normal operations in seconds, while replica pool updates are fully transparent to users. And finally, we'll talk about this more in a bit when I cover how easy AlloyDB is to manage. We've done a lot of work to make sure that other reliability issues you see, like out-of-memory errors and out-of-disk errors, are a thing of the past. Writes on AlloyDB scale linearly with core count up to the largest instance supported on Google Compute Engine. Reads scale horizontally with loads balancing across more than 1,000 vCPUs. Each read replica has its own vectorized columnar store that's auto-populated by access pattern recognized by the machine learning algorithms on that replica. And of course, storage scales automatically as well, due to that scale-out intelligent storage engine I described earlier. Talib is going to show us how seamlessly read connections scale with AlloyDB.
Hi, my name is Talib Osterg. I am the engineering manager for AlloyDB read pools. Read pools allow you to horizontally scale read connections by adding more nodes. Today, I want to show you how you can increase your read performance by adding more nodes. Here I have a cluster with a primary and a read pools of 2 nodes. I'm expecting an increase in traffic, so I want to double the read capacity of my cluster. It's very simple. Just edit the pool and change the node count from 2 to 4. Because this update takes a few minutes, I created another cluster with multiple pools. As you can see, the first pool only has 1 node, the second has 2 nodes, and the third has 4 nodes. They are all backed by the same primary and the same database storage. That means, regardless of the endpoint I connect to, I will be querying the exact same database. Because node counts are different, I expect that my query per second should double from 1 node to 2 nodes and 2 nodes to 4 nodes. Let's see if that's the case. Here I have a client VM, and I will be running a standard pgbench select-only workload for 10 seconds. Let's run it against the first pool with 1 node. Its IP ends with 28. It is 71,000 transactions per second. Let's try the pool with 2 nodes. Its IP ends with 15. Just going to change the IP, and that should double, and it should be more than 140,000 per second. Great, it's 149,000 transactions per second. Now let's see if we can double it again. This time we're going to be connecting to the last pool, and its IP ends with 19. That should be around 300,000. Awesome! 300,000 transaction per second. As you can see, we can linearly scale our read performance by adding more nodes. I can scale up and down in just a few minutes at any time. It's super easy to make sure you have the right capacity for your workload. I want to show you one more thing before we end our demo. As I said before, all these read pools are backed by the same primary. So what happens if the primary dies? Can we still use the read pools? Let's see. First, let's see if we can connect to the primary. I'm just going to use PSQL. Primary IP ends with 2, so I'm just going to connect to it. Great, we can. Now, I'm going to crash the primary and also hit standby with this command. Now let's see if we can access the primary. Primary is definitely down. Let's see if we can access the read pools. Great! Even if the primary is down, read pools can continue running just fine. Hope you enjoyed the demo, and thank you for your time. Back to you, Andy.
That was an awesome demo. Thank you. AlloyDB is also really easy to manage. We use machine learning and other adaptive algorithms to provide comprehensive database monitoring, troubleshooting, and optimizations. AlloyDB features autopilot systems to help both automatically manage and dynamically adapt the database systems to the needs of the customer workload they're running. You no longer need to worry about complex database management tasks such as memory management, vacuuming, and data tiering. AlloyDB automatically addresses them for you. AlloyDB seamlessly integrates with Google's portfolio of distinctive AI and ML services. For example, Vertex AI will be available at launch for easy inferencing with AlloyDB databases. We're also making it easy to build machine learning directly into your applications with intelligent transactions. AlloyDB is pre-integrated with Vertex AI, Google Cloud's artificial intelligence platform. Developers can create a model in Vertex AI and then call it within a query or transaction. For example, a payment processor can immediately flag a new transaction in flight as fraud. You get high throughput, low latency, augmented transactions without having to write any additional application code. We're really excited about the new capabilities that AlloyDB offers, but we also haven't overlooked the basics, the awesomeness of Postgres that brought us here in the first place. AlloyDB is fully compatible with Postgres, including broad extensions and Flask support. We're launching with Postgres 14 compatibility, but we'll have cadence with the latest releases. So as Postgres gets better, AlloyDB will get better too. Move your Postgres application as is with no need for application changes. Just use pgdump and pgrestore or use our database migration service. And finally, we know cost is a concern for developers and enterprises alike. That's why we're committed to predictable and transparent pricing. No license fees, no opaque I/O charges. Simple, usage-based pricing for both compute and storage with industry-leading price performance. But don't just trust us. Here's what some of our customers are saying about AlloyDB. From Deutsche Bank to Nokia to PayPal and more. Leaders love it as it allows them to modernize faster and reduce costs, and developers love the Postgres compatibility along with the scale and performance of AlloyDB. AlloyDB is helping customers do something they couldn't do before, whether it's modernize an existing workload in the cloud, solving a scaling issue, reduce management overhead, or enable real-time insights. What this means is that for your Postgres workloads, we offer you not one, not two, but 3 fully managed services. Cloud SQL is our enterprise-ready, fully managed relational database service for Postgres, MySQL, and SQL Server. You get the exact same awesome, open Postgres you run elsewhere with strong management, availability, and security capabilities of Cloud SQL. AlloyDB is our fully Postgres-compatible database, ready for your top-tier workloads and for modernizing your legacy proprietary databases in the cloud. And then, of course, Spanner, which is our transformative relational database service with unlimited global scale, strong consistency, and up to 5 nines availability. We have also introduced a Postgres interface for Spanner so that developers can take advantage of Spanner using familiar tools and skills from the Postgres ecosystem to build transformational applications that need unlimited scale and always-on availability. we strongly believe that Google Cloud is the best home for all your Postgres workloads. Now, to help more enterprises standardize on Postgres, we recently announced Oracle to Postgres schema and data migration support in Database Migration Service. This offers a heterogeneous migration path for Oracle to Postgres. Database Migration Service integrates with the Ora2PG open source tool for schema conversion and provides serverless data movement and monitoring for your migrations. This is available in preview for Cloud SQL, and we expect to support this for AlloyDB in the near future. Database Migration Service will also support easy upgrades from Cloud SQL to AlloyDB, so you can run your Postgres workloads on Cloud SQL now and rest assured that you'll be able to later move them easily to AlloyDB to take advantage of AlloyDB's unique and differentiated capabilities. Lastly, we know that migrations can be challenging. Therefore, we have invested in a comprehensive end-to-end program to help make your migration experience fast, easy, and cost-effective. We have recently announced the new Google Cloud Database Migration Program. This program provides tooling and resources for assessments, project planning, and implementation. These efforts are further amplified with incentive funding designed to reduce the cost of your migration. Take advantage of this program and offer by getting in touch with your account teams today. So here's how you get started with AlloyDB. You can create a cluster right away using our UI, API, or gCloud CLI tool and start ingesting and querying data. If you're coming from Postgres, simply use pgdump and pgrestore to get some data into AlloyDB. And with the introduction of AlloyDB, this is what our rich cloud databases portfolio looks like. We're excited about the business and technical transformations our databases can drive for you. So I invite you to try the preview of AlloyDB today. We're offering the preview for a limited time at no charge. Learn more at cloud.google.com/AlloyDB. With that, I'd like to thank you for joining us at Google I/O. We hope to partner with you to modernize your databases and accelerate your data-driven business transformation.